shit just got real here on the Astro 30's Electronics Lab. Greetings, the Astro 30 here yet again, and what am I talking about? Well, I've just finished over the last 2.5 hours routing out the PCB for the Champ 1 watt amplifier, as previously discussed in another video, and this is the 3D model of the circuit board. So it's a double-sided through hole, plated through hole. So most of the ground tracks are on the top. There is one positive route going between this capacitor over here and this transistor over here, because there wasn't room to put it on the bottom. It made it awfully awkward. And I'm using, I think it's 0.6 of a millimeter track width, something like that. Anyway, I've made the board so you could have edge connectors, like plug connectors here. The LED can also be converted to a plug connector. The variable resistor can also be converted to a plug connector. So you can actually mount with the screw holes to the bottom of a box, whatever, and have wires running off to the various controls. There's the actual physical layout in 2D mode. You'll notice over here we've got J2, which is marked as boost. That is to bring this capacitor C3 to ground, which is going across resistor R5 and ground off the emitter of Q1 to control its gain. So putting the capacitor across there will increase the gain of this transistor, will actually make this transistor operate at its full gain. Now, this section here is an input preamp, single transistor class A, before the volume control, and here is the 1 watt Darren Yates output amplifier over here. And here is the redrawn schematic, so it's a little bit clearer, and the astute viewer will notice that the blocking capacitors all the way along the circuit have been changed to 0.47 microfarad or 470 nanofarad. Reason for that is I want to lower the bass a little bit because I'm going to be driving a smaller size speaker, a 76mm, instead of a 100, so I don't actually need to have that much bass going through it. And the area I'm going to be focusing on is this input preamp stage with the boost circuit. I need to work out what the value of this resistor really needs to be. I've put it at 220 ohm to start with. Good starting point. I want around about 2 volt out here peak to peak before clipping, and the ability with the gain switched out around 200 millivolt input, and with the gain switched in around about the 20 millivolt range, 10 to 40, something like that, just so I've got a little bit of switchability between gain. So I'm going to build this part up on a breadboard and test it, and then I'll connect it to the rest of the circuit and see how it performs. Okay, got the little circuit built, and I'm using that 50k variable pot here just to adjust my emitter resistance. I've got it currently set around about the 220 ohm mark. I have that frequency generator set at 1 kilohertz, roughly a 200 millivolt output, and when I connect the supply up I don't really want to see any more than about 2 volt peak to peak on the output. 1 volt would be better. 2 volt gives it a little bit more headroom. So I'll just connect up that. And we've got a lovely 1.6, 1.7 odd volt peak to peak, and the output is not clipping. So if I lower the gain pot and lower the time base, well, the amount of peaks, it is starting to clip. See, as you can see at the bottom there, it's clipping asymmetrically. So I'll just back it off Now I'm getting clean 2.9 out, but I think that's a little bit too far. So I want to drop that down to around close to 2 volt mark. I reckon should be pretty good for that. Now I need to measure the resistance of the pot. And according to that, we're closer to 330 ohms, which is okay. That's doable. And as I don't have a 330 ohm resistor, I've just put a 220 ohm resistor and 100 ohm resistor in series with each other between emitter and ground to give me the 330. Well, actually 320, so it's close enough. So I'll just power the circuit back up. Hopefully nothing's moved. Yeah, there's a difference now. I've got 2.26 volt out, but that's still okay. It's not clipping or anything. That is perfectly acceptable. Okay, so now I want to simulate that capacitor, that 10 microfarad capacitor being switched in and out across that resistor bank. So I've got a little wire and the capacitor going over here. It's all over the place, but it's just for testing purposes more than anything else. You can watch the scope screen whilst I connect the wire to the ground. And we've overshot. And we are slightly clipping. Okay, so I need to lower my input of the generator till the clipping goes away. And we get roughly the same amount of voltage out, which is 2.2, I reckon, I think it was. And I think it's 2 point something, wasn't it? Yeah, there you go, 2.2, that's roughly about it. And so now I'm measuring the input voltage and it's more like 100 millivolt. I want it lower than that. Right. Now we're at 10 millivolt. Alright, with the capacitor installed, I'm getting 1.93 and I've lowered the volume of the generator. Now I need to figure out, when it's at 3%, what that actually is as an output voltage. So according to that, that's 40 millivolts, so that's about right actually. So I'm going to say that the 40 millivolt mark is even the 10 millivolt to 40 millivolt mark is about right for that. So I'll just hook this back up the other way and I will disconnect the capacitor, drop back down to 480 millivolts, 500. So with the capacitor in, like really, dude? With the capacitor in, it's not making good contact. The capacitor in, we're getting more like 1.9 out. So I'll take the capacitor out of circuit, wind up the thing till we get roughly the same voltage reading, which is 1.9 out, and I'll connect the input to the scope. Yeah, we've almost got 200 millivolt in, so I'm going to say that's roughly right. We get a 2 volt output of 200 millivolt and 40 millivolt, respectively, with the capacitor switched in and out. I have the two circuits now connected together, and we're measuring the output of the champ. I'll just rotate this pot up. As you can see, we're getting an increase. We're now at 1 volt, and my control is about 1/4 of the way turned up, which is about roughly where it should be. That's with 200 millivolts in. It's a bit jumpy. There you go, we're almost up to our full output. Now we're up to the full output. Beauty. Now I'll just test it with the, I think it was 10 millivolt input. So I need to connect that capacitor up. I assume it's connected. It's hard to tell with this board. It sometimes doesn't want to make good connections. I think it is trying to connect and it's not connecting. Let's try that again. Oh yeah, it's connected. Alright, so I'll drop the input volume down to 3% again, which is roughly where it was. Whoa. Breaks up right at the top end. Okay, that might appear as a squeal. And the only way to test it really is with a speaker connected to it. So, oh, nasty oscillation there. Okay, let's kill that. Appears to be oscillating. That's not ever good. Jeez, bad connections. Okay, it does work apart from that oscillation. It's probably because of all this exposed capacitance and wires and crap going everywhere. It's causing an issue. Possibly on the actual real PCB that won't be an issue. Well, it shouldn't be. But these boards are picking up weird oscillations from somewhere anyway. Okay, so now I have my final design. I'm pretty sure that it's right. Now I can go ahead and have the PCBs manufactured and actually build it up on a PCB and see how it sounds. I don't want to do it on Veriboard because it's a pain in the ass to lay out. Well, I just went to order the PCB on JLC PCB and the total is going to cost me $62.30 because there's a surcharge for a remote area of $24.64. Okay. Which probably means that I'm going to be selling a few of these boards to anyone that's interested. Do I do it or do I not do it? That is the question. So, should I do it or should I not do it? It's going to cost me $62 to have 10 PCBs made. I only really need one, so I'm thinking about selling the remainder of the PCBs if anyone's interested. And if anyone's interested, drop a comment because I'm planning on probably selling the PCBs for around about the $10 mark Australian. I think that's fair. Yeah, Mum. No, that's a little bit much more manageable. That's about nearly $20 Australian, which is much more acceptable. I went with PCB Way in the end, and you can change the shipping method. DHL wants $60.35 US for the delivery because there's a $24 surcharge for out of the country delivery. That is ridiculous. And look at the prices for, say, like FedEx IP, FedEx ICP. On a small board that's 62.5 by 47.5 millimeters is fucking ridiculous. So I went with global standard. Go global standard shipping. It's 8 to 11 business days and is only $6.50 US. Or 56 cents US, I should say. So I'm going with that delivery method, and I'm going to pay roughly $20 Australian and have the boards made. It'll take a month to get here. All well and good. And this is what the PCB is going to look like when it comes in. The camera doesn't do it justice, it's a nice dark blue. That's the front. And that one is the back. Isn't that sexy? Anyway, I'm going to leave this one here. I'm the Astro 30. If you enjoyed this video, please remember to like, comment and subscribe below. And you can always follow me on Facebook or become a Patreon for as little as $1 a month. The links are in the description as usual. Anyway, this is Astro 30 saying see ya. Have a great day.